Welcome back to Module 2. So as I mentioned, with Chapter 7, Module 1 is by far the longest module. I think it was something like 39 slides. This one's only just 20, a bit less than 20 really when you take into account the cover slides and stuff. And then I think the next one is kind of similar to that, like 15, 20 slides. So it shouldn't take us too long to get through. So this will be your lecture for Friday, October 2nd, but you can also take time to finish off the end of the first lecture for the first module because this one just won't take the whole 50 minutes for sure. So, Module 2 is about encoding and retrieving memories. So last module, we talked a bit about how memories are formed and the different storage components of memory. Now we're going to talk a bit more specifically about how we actually encode our memories, so the best ways for us to encode information so that we can remember it long term, and also how we retrieve our memories. And then finally in the third module, we'll get into a little bit about when memory fails us. We might create false memories and things like that. Oops. So, remember from the first module that the definition of encoding is basically the process of transforming sensory and perceptual information into memory traces. So you're basically taking that sensory information and the perceptions that you kind of get in response to that sensory information, and you are kind of solidifying them and putting them into your long-term memory in a way that they can be retrieved at a later time. And then retrieval, on the other hand, is the process of accessing this memorized information in order to make use of it at present. So basically, in order to get our memory to stick around long term, we want it to undergo encoding in between the short-term and the long-term memory stores. And then in order to bring that memory back into our present awareness, we're going to need to retrieve it from long-term memory. So rehearsal is one of the methods that we talk about in terms of encoding new information, but its effectiveness does vary based on the type. So rehearsal is basically any time where you're prolonging your exposure to information. So you can have something called maintenance rehearsal, which is basically prolonging your exposure to information by repeating it. So think about in that example that I gave in the last class for working memory of the person who's trying to remember the phone number while they're trying to pull over and call the radio station to win that trip. So maintenance rehearsal would basically be what they were doing there with the phonological loop. If they're repeating that number over and over and over again in order to keep it in their short-term memory, keep it kind of in their present awareness, then that would be maintenance rehearsal. Elaborative rehearsal, on the other hand, is something that can lead to more long-term remembering. So instead of just prolonging your exposure by repeating the information over and over, which obviously keeps it in your mind for the time being but doesn't really kind of solidify it for you, elaborative is when you prolong your exposure by thinking about what it means and associating it with other things that you know. So if you take, a concept and you're able to relate it to something from your real life, something you've experienced previously, if you take, the word and you break it down into its meaning, and then you see how the parts of the word are related to what they actually mean, then that is going to provide you with a better chance of being able to retrieve that information at a later point. So it's going to help with your encoding process. So while maintenance rehearsal can help us remember for a short time, the elaborative rehearsal is the one that will really improve your long-term learning and remembering processes. So here are some examples here that kind of show the limit of maintenance rehearsal. So if a participant is asked to read a 4-digit number and try to remember it, and then they're asked to repeat a word, so they have to say the word over and over and over again until the experimenter tells them to stop, and then they're asked to try to recall the number. So it looks like what they're asking you here, what the main purpose is to try to remember the number, but really what experimenters were actually trying to test is whether or not repeating the word over and over again made you more likely to be able to recall that word. So then the numbers were it was a little bit deceptive in this case. They were using the numbers to make the participants think that's what they should be focusing on, but in reality they were testing their recall for the word that they had repeated. And what they found is that it didn't matter whether they were asked to repeat that word for 2 seconds or they were asked to repeat it for 18 seconds. It didn't actually make a difference in terms of their ability to remember that word. So even if they repeated it for 18 seconds in a row, it still didn't really commit it to their long-term memory. So we saw that maintenance rehearsal, while it can kind of keep that memory in your kind of current awareness for a brief period of time. As soon as you stop repeating or rehearsing that information, you're probably likely to forget it pretty quickly. A very related concept is levels of processing. So the levels of processing framework states that our ability to recall information is directly related to how that information was initially processed. So again, just like elaborative rehearsal basically makes it easier to encode information and then subsequently retrieve it than maintenance rehearsal, deep processing will provide an advantage over shallow processing in terms of the ability to later recall that information. So shallow processing, just like maintenance rehearsal, involves more superficial properties of a stimulus, such as the sound or the spelling of a word. So thinking about what a word looks like or what a word sounds like, that is basically going to be a pretty shallow level of processing because you're not actually acting on that information in any way to remember it. Whereas deep processing, on the other hand, just like when we talked about elaborative rehearsal, is more related to an item's meaning or function. So if you're able to actually associate the meaning of that word with something about, you know, how the word looks, or maybe break the word down to components and kind of associate the meaning of the components together, it's going to make it a lot easier for you to remember that information. So basically what we're seeing here is that shallow and deep processing are kind of similar to maintenance and elaborative rehearsal in that the shallow processing and the maintenance rehearsal are good for kind of short-term remembering, but they probably don't lead to kind of long-term memory change, whereas the elaborative rehearsal and the deep processing are going to lead to kind of a greater change over time and an improved ability to remember that information. So again, just like we saw with the maintenance rehearsal and the elaborative rehearsal, shallow processing can be useful at times, but deep processing is usually more effective. It actually involves converting the information to long-term memory, which might explain why it is hard to retain material that has little or no meaning to you. Because if you can't kind of conceptualize what it means and relate it to something about you or something that you already know, it's going to be a lot harder for you to remember that information. And a very related concept, and one that I've kind of alluded to a couple of times now, is the self-reference effect, which is thinking specifically about how information relates to or is useful to you. So it's a specific kind of deep processing, which is not only thinking about the information's meaning, but also trying to relate it to something you know or how it could be useful to you in your life. And of course, that again would make it a lot easier for you to kind of remember and recall those concepts at a later time. So here's just a little bit of information about the levels of processing and how they affect the long-term memory but not the working memory. So you see that if somebody was tested immediately after studying some words, so say if they had a list of words, and in one group, say they were asked to do shallow processing, so they were asked to just basically look at the words, think about how they sounded, how they looked, and try to remember them, and you had other people who were asked to kind of give a deeper meaning to the words and associate them with concepts they already knew or try to relate them to something, we saw that if you test them immediately after they see the list, of course, there doesn't seem to be much of a difference in terms of the proportion of correct words that they recall, which makes sense because at that point, if they're tested immediately after, a lot of those words are probably still within their short-term memory. However, if you put a gap in between studying the words and being tested, so you basically don't allow for that information to be kind of maintained in the short-term memory, then we see that the ones who were asked to process the words deeply and actually think of like a meaning and a function for them were much more likely to remember a higher proportion of the words than those who did a more shallow form of processing. So just looking at them, thinking about how they sound, maybe saying them out loud, did not lead to as well, I guess, as good recall or retrieval as did processing them in a much deeper way. So we definitely see that it would definitely affect your long-term memory recall more than it would affect your short-term memory recall. So speaking of retrieval, once a piece of information has been encoded, either explicitly or implicitly, and all that means is either you explicitly tried to commit it to your memory or it kind of implicitly kind of made its way into your memory. For example, like what you ate for lunch yesterday, you probably didn't sit there and stare at your sandwich and think, I'm going to remember this tomorrow, but sometimes we just pick up on that information kind of automatically. So regardless of whether it was encoded explicitly, like on purpose when you're studying for a test, or implicitly, just kind of daily life events that you kind of keep in your mind even if you don't try to, we must be able to retrieve it when it is needed. So with respect to explicit memory, which again is the kind of information that you can explicitly state that you have, that you know, it kind of relates to those declarative memories we would have talked about in the last module. So explicit memory refers to the conscious, intentional recollection of an event or an item of information, which is measured using two methods. So if you're trying to actively remember something you read, for example, if you are completing our tests, you are going to be using your explicit memory because you're trying to consciously recall information that you've learned. So recall refers to retrieving information when asked, but without that information being present during the retrieval process. It can be helped, however, substantially by retrieval cues. So if, for example, and it's not a very good example this semester because of course everything is kind of open book, but say if you were in my classroom last semester, in the winter semester, I would have given you a test that would have consisted of 30 multiple choice questions and 20 marks worth of short answer questions. And you would have come into class during class time and completed it just like you would have completed your test in high school or anywhere else that you've undergone testing. So in that case, if you looked at the short answer section and I asked you to answer a question for me, that would be a test of your recall for that information. So I'm not just giving you the information and asking you to recognize what it is, I'm asking you to actually recall it from your memory. But it might be helped if I gave you cues in the question. So maybe I mentioned a specific example in the question that I'd use in class. Maybe that might act as a retrieval cue that would allow you to kind of bring back that information a little bit more easily. Recognition, on the other hand, involves identifying a stimulus or a piece of information when it is presented to you. So you don't have to retrieve it out of the blue. You're given a list, such as in a multiple choice question, and you're asked to pick which one it is. So basically, in that test example I gave, the short answer questions that you would respond to in that test would be considered a test of your recall, whereas the multiple choice would be a test of your recognition, because you don't have to come up with it out of nowhere. You actually just have to recognize what the correct answer is from a list of alternatives. Recognition tasks can definitely be tricky. I mean, I'm sure you've all seen multiple choice questions that were a little complicated, that they, had maybe two answers and you had to pick which one was best. But on average, recognition tends to be easier than recall for most people. So people tend to do a little bit better on tests of recognition memory than they do on tests of recall. Because, of course, the answer itself being in the question, like that it is one of the choices, that kind of acts as its own retrieval cue in that case. So here's a little example that I like to give. And obviously, again, just like the other example in the last module, it doesn't work quite as well online, but you can still try it out. If I asked you right now off the top of your head to name Santa's reindeer, how many of them could you just name out of nowhere? If you know the song Rudolph, you probably could name most of them, but outside of that, just think if you were just trying to kind of recall their names, it would probably be kind of a tricky task for you, right? But if I then gave you this list and I said which of these are the names of Santa's reindeer, that task would probably be a little bit easier for you to complete. And so basically what we're illustrating here is that the first task, if I just asked you to name them outright, would be an example of a test of recall. I'm asking you to recall their names without giving you any kind of hints or clues or retrieval cues. Whereas in the second example here, I'm asking you to perform a recognition task because I'm giving you a bunch of names, you just have to pick which ones are the right ones. So you can kind of see, hopefully through this example, that it tends to be a lot easier for you to pick things out of a list, so to kind of test that recognition memory, than it is to test your recall. Now we're going to talk about something that I find really cool, which is known as the encoding specificity principle. So researchers have found that retrieval is the most effective when it occurs in the same conditions as encoding. So this is known as the encoding specificity principle. And this is something that you as a student can use to your advantage at times. So for example, if every time you listen to my lectures, you're sitting in a specific chair, or you're sitting at a certain desk, or maybe you're sitting at a kitchen table, it would actually benefit you to then do your tests and assessments in that same location, because basically what they say is that there are typically some kind of cues in the environment, if you're in that same environment, in those same conditions, that act as retrieval cues to help you out with your recall. So your text uses the scientific literacy model to review one form of encoding specificity, which is known as context-dependent memory. So this is the one I was kind of just using in that example. It's the idea that retrieval is more effective when it takes place in the same physical setting or context as the encoding. So again, if we were on campus and you sat in the same seat in the same classroom to do your test as when you're there and I'm lecturing, you would be more likely to do better on that test than if we basically took you and put you in a different environment for testing. And something that has always kind of bothered me about this is, by this logic, it would mean that taking your final exams in your classroom would actually be more benefit to you than having to take them in like a gymnasium. But again, I understand why there are kind of constraints there, because it's a lot easier to supervise a bunch of students if they're all in a gymnasium rather than in a classroom. But technically, according to context-dependent memory, you would probably have a little bit better recall if we did test you in the same classroom that you took the class in. So context-dependent memory has actually been tested in members of a scuba club. This was a really interesting example of a study that is measuring that concept, and I have an example, I think, from it on the next slide, so we'll go through that. But it definitely did demonstrate that context affects your memory. This may have to do with our encoding and how it works. So basically what happens is, when we're encoding information, we don't just encode it from one of our senses, we tend to encode it from a number of senses at the same time. And so basically, context-dependent memory would work because if you're in that same physical setting, you're likely to have a lot of the same sights and same sounds and same smells and things like that around you. So those things might actually act as retrieval cues for helping you retrieve your memories. So here's the example of the scuba divers I was talking about. I apologize, I'm coughing and sniffling still a little bit today, but hopefully it's not too distracting. So in this case, they basically took divers and they gave them information to remember, and they either had to learn the information on land and recall it on land, learn the information while underwater and recall it underwater, or vice versa. They might learn it on land, recall it underwater, or learn it underwater and recall it on land. And basically what they found is that divers who encoded the information on the land had better recall when they were on the land again. So being in that same physical context gave them kind of a retrieval cue, it seemed, and it made their recall better. Divers who encoded information underwater had the reverse experience. So they showed that they could recall that information then better underwater than they could when they were on land. So that's a really interesting example, because it clearly shows that their retrieval, their recall for the information, seemed to be influenced by the context in which they encoded the information in the first place. However, we have found that not all types of memory appear equally enhanced by context. So of course, it kind of makes sense that recognition memory wouldn't be significantly helped by the context, because in an example of testing your recognition memory, the answer is going to be there anyway, right? So the fact that the answer is in the question, such as in a multiple choice scenario, that's going to provide its own kind of really strong retrieval cue for you. So context-dependent memory tends to work a little bit better when we're talking about testing recall. Also, not all types of information are equally affected. It seems like information central to a memory episode, so the main focus of what it was you were doing or what it was you're recalling, that seems to be not as affected by the context. And in fact, returning to the context may actually increase false positives in some cases. So sometimes they say, return to the scene of the crime. They're usually talking about the perpetrator returning, but sometimes they'll take a victim back to the scene of the crime to try to get them to kind of see if they can recall what happened. And unfortunately, sometimes being in the familiar context can generate memories, but they may not always be accurate. So one of the most interesting implications of context-dependent memory research is that it implies that some forgotten information may not be gone forever. So there may be some ways in which we can help improve people's recall and maybe get them to recall memories that they seem to have lost. It may just simply at the time be inaccessible due to the loss of retrieval cues. So this may aid police officers, but again, I would caution that we have to make sure we're not causing false positives, because that can happen in some cases. So here's an example of false familiarity and how context-dependent memory can actually be kind of a detriment at times. So they basically did a study where you had to identify the thief in a staged robbery. So they staged a robbery, they got participants to view the robbery, and they later had to select the thief from a lineup of photographs. If both of the stages of the study, so when they asked them to view the video and then when they asked them to identify the person, were performed in the same room, and that would be giving you that same context, identification of the thief increased, so they were better able to identify him, but participants were also more likely to rate an incorrect face as being familiar, which is shown by the lower accuracy score in the same then for different contexts in the target absent condition. So you see in the target present, if they showed them a bunch of photographs and the thief was actually in the photographs, they did do a better job of identifying him. You can see with the column that says same under the target present column there, or target present section, you can see that they were better at identifying him in that case. But in the target absent condition, so when the thief wasn't actually in the pictures, when they were in the same context, it actually decreased their accuracy because they were more likely to rate a face that they hadn't seen as one that they had seen. So it kind of like seemed to have created a false memory in them of having seen the person that they actually hadn't. So you can see how it can be both beneficial and detrimental in a way. And finally, we talked about encoding specificity being in the same kind of situation and how that can help our recall. So far we've mostly focused on the same physical situation, which is that context-dependent memory. But just as your memory can be influenced by context, it can also be influenced by your internal state. So state-dependent memory basically says that retrieval is more effective when your internal state matches the state you were in during encoding. So for example, intoxication. And this one, the study that they did here was particularly fascinating. Basically what they did is they got a bunch of people to either drink or not drink while they were trying to remember a list of words. And so the ones that were drinking during encoding, so drinking when they were trying to remember the word, so they were kind of, well, I guess at that point they were intoxicated, they were drunk, and they tried to remember the words. And then they would either test them when they were sober or when they were drunk again. And then the ones that were sober in the beginning were either tested when they were sober again or another point when they were drunk. So basically what happened is obviously the ones that were sober in both scenarios did the best, because, you know, being sober would definitely help your recall overall. But the second highest group in terms of their accuracy was the group that were drunk during encoding and drunk during retrieval. So it seemed like putting them back into that same state of intoxication during recall actually did aid their retrieval of information, which is kind of counterintuitive because you think the drunk people will be less likely to remember in general than all the other contexts, but they actually performed kind of the best after the ones who were sober in both cases. We've also seen that mood can influence retrieval. So mood-dependent memories are when people remember better if their mood at retrieval matches their mood during encoding. So for example, if you are in a really bad mood or you're feeling really sad, you're more likely to remember memories in which the content is sad, so times in which you were sad before. If you are in a really happy state, it's a lot easier for us to remember memories of when we were happy, or memories in which the mood is kind of more joyous. So that's really interesting and can be really detrimental in things such as depression, because you can think logically if a person is depressed and they're really feeling low and kind of down about things, and this type of mood-dependent memory makes it easier for them to recall times they felt sad or recall times when bad things happened, that can actually lead to kind of perpetuating that depression. So it's really important to kind of understand these encoding specificity principles and how they work. So overall, it is clear that context can affect our ability to retrieve certain memories. Even just walking back into a room when you've forgotten what you left the room for which would be context-dependent forgetting because you forgot once you took yourself out of the context, can help you remember what you need, which is called the context reinstatement effect. So I don't know if you've ever done this, but I do this quite frequently, where if I leave my office to go to the kitchen for something, and then halfway there I forget what I needed, I will actually come back into my office. And chances are, once you get back in that same situation, it kind of jogs your memory and you remember what it was you left for. So we can definitely use encoding specificity to our advantage. I'm so sorry, I keep having to start and stop the recording, so I hope it's not noticeable in the video. I'm starting to lose my voice, I think, so every now and then I have to kind of stop and clear my throat. So hopefully you're bearing with me and we can get through the next 7 slides, okay? So now we're going to talk a bit about emotional memories. So emotion seems to act kind of like a highlighter for memories. It makes them easier to retrieve, so easier to kind of latch onto. Emotional stimuli and events are generally self-relevant. Obviously, if you're super happy or super sad about something, it's probably something that means quite a bit to you. It's important to you. And they're associated with arousal responses. So for example, if you are in a situation where you experience fear, you're likely getting arousal of that sympathetic nervous system, and the amygdala in your brain. And so the heightened arousal that you feel in those situations physically can actually help lead to deeper processing of information. However, we do find that emotion has fairly specific effects. People often focus their attention on the emotional content of the scene, which is more likely to be remembered. So this, unfortunately, can be troublesome in a courtroom. So for example, if somebody were witness to a robbery, that was probably a pretty emotional experience for them, and therefore you would think that they'd be more likely to remember a lot about it or remember a lot in detail. But unfortunately, because people tend to have that focus that kind of hones in on the emotional content, you might actually miss other information about the scenario. So for example, there's something called weapons focus, where in the case of armed robbery or an assault or something like that, sometimes the victim or the witnesses tend to kind of hone in more closely on the weapon that's being used. And so they might not really notice subtle details about the person who's holding the weapon, because the weapon to them is the thing that's causing them the most anxiety. And so therefore they kind of focus in on that, and that might make some of the other details a little more fuzzy. So we find that the memory enhancing effect of emotion is strongest after long delays. And we do find that emotion has largely influenced consolidation. So it's not necessarily that when you are in an emotional situation, you tend to... Sorry, I had to pause because the dog was barking. So basically we find that it's not necessarily that emotion will make your short-term recall a lot better, but that it actually does make those memories not only more vivid in the moment, but also be more likely to encode it into long-term memory. So the effects that we see are largely on, recall after a delay of time, because we actually have committed that information to our long-term memory. It's interesting to note that emotion can influence memory consolidation even when the stimuli themselves are not emotional in nature. So for example, word lists. And I believe I have an example on the next slide here to go through with you. Yes. So in the case of does emotion improve memory? Some people think, okay, it improves your memory for the emotional event itself, but we've actually found that being in a heightened sense of arousal, and in terms of emotional arousal, can actually just make you remember anything that occurs when you're in that state better. So there was a study conducted in which the researchers asked 2 groups of people to study a list of words. And then they did a pretest for their word memory. So they wanted to rule out the effects that maybe one group was just better at remembering than the other. So they tested them immediately after to see how much they could recall. Then they had one of the groups watch a surgery video. So even though what they were asked to remember was just kind of a list of words, they made them watch a surgery video, which is probably likely to kind of create a high amount of emotional arousal in the person watching it, because most people, are nervous of or may even fear surgery. Whereas the other group had to watch another video, because again, they wanted to control for any confounding effects, but it was just a video of people brushing their teeth. So it wasn't something that should be overly emotionally arousing. So what they found is that even when asked later to recall that list of words, the ones who had watched the video that had that level of emotional arousal to it, the surgery video, they actually showed a higher recall of the word list after 30 minutes. Whereas the ones who had just watched the teeth brushing video showed lower scores on their 30-minute recall test. So it actually seemed as though even though the content of what they were remembering, the list of words, wasn't emotional itself, having undergone an emotional experience right afterwards actually increased their ability to kind of consolidate that word list and bring that memory back when they were tested for later recall. Researchers have also identified many biological mechanisms that allow emotion to influence memory. So I mentioned this one a second ago, but structures in the temporal lobe, such as the amygdala and the hippocampus, play a major role. So the amygdala is particularly known for its influence on memories that contain elements of fear or aggression, so if you're mad or if you were afraid. And then the hippocampus is actually, we talked about this in the case of HM, it's one of the most important parts of the brain in terms of memory consolidation in general. So there's one particular type of emotionally charged memory, which is known as a flashbulb memory. So it's named after the kind of flash that you used to get on the kind of old-time cameras with the big kind of bulb that flashed when they took a picture. And it basically refers to an extremely vivid and detailed memory about an event and the conditions surrounding how one learned about that event. So basically what we're talking about here is that if there is an event that had, a highly emotional nature to it, you're more likely to have a memory of that event that's very vivid, and it looks almost like you can see it like a picture. So that's why they call it a flashbulb memory. It almost looks like you took a super clear picture of what happened and you're able to recall it in your mind. However, and this is really important to note, even memories that are extremely emotional in nature can be subject to decay over time. So decline in memory for the details of an event over time occurred for both flashbulb and non-flashbulb memories, despite people typically being more confident in the accuracy of their flashbulb memories. So it makes sense if you have a memory that is of an emotional event that you perceive as very vivid and being very realistic, you will be more likely to think that you'd be more accurate in recalling that memory. So examples of flashbulb memories might be something like a memory of a wedding or a graduation or the birth of a child, or it could be something negative like the death of a family member or a loved one. So basically what they're saying is whenever the memory is super emotionally charged, you're more likely to remember it as more vivid. But we do see errors creeping into the details for both flashbulb and non-flashbulb memories. So for example, there was a study where they examined people's memories of 9/11, which is of course when the World Trade Center in New York was, the towers were struck by planes and a lot of people died. So it was a very vivid event for a lot of people who experienced it. And so they basically started studying people right afterwards, and they asked them about kind of benign things that had happened within the days preceding the 9/11, and then they also asked them about their memory of the day of 9/11 itself. And what they found is even though people were more likely to keep rating their accuracy of the memory of 9/11 as more, like they thought they were more accurate in recalling it than they did for the random memories from the other days, there were still small errors that started to creep into the details of both types of memories. So the major pieces of the memory were recalled, but the details started to kind of deteriorate for both. So early research into forgetting was conducted by a man named Hermann Ebbinghaus. He found that forgetting occurs most rapidly at first, with the rate of forgetting leveling off fairly quickly after a few days. So he basically called this pattern a forgetting curve. He said that most of your forgetting is going to occur right away. So within, a day or two, if you look at the graph here, you see that within the first 60 hours, pretty much all of the forgetting has occurred. And then eventually the rate of forgetting kind of slows to the point that one does not seem to forget at all. So it basically seems like, after about 60 and especially after about like 120 hours, it starts to level off, and you're a lot less likely to forget things after that. So it seems like whatever you don't consolidate within that first short period of time is eventually going to be lost and not really committed to memory. So now we'll talk briefly about a couple ways we might be able to help improve our memory. So we can use devices known as mnemonics. So a mnemonic is a technique intended to improve memory for specific information. So there's a number of different mnemonics. I'm sure you've used some of them before. You may not have known that term specifically. But there's one called the method of loci, which is a mnemonic that connects words to be remembered to locations along a familiar path. So, and I think this might be in your text, either that or it's in the old text, but it's kind of a silly example that really kind of highlights what this means. So say that you're trying to remember a grocery list, and you've got, 5 or 6 items on the list, and you want to make sure you remember to get them all. So what you do is you take a familiar path in your mind, so maybe it might be the route that you walk to the university every day, in a normal semester where you are walking to the university. And so there might be landmarks that you see along the way. So maybe you pass Superstore, maybe then you pass a church, maybe you see the soccer field. And so basically what you do is, because that pathway is so familiar to you, you start to connect the words on your list that you need to remember with kind of those hallmarks along your journey. So for example, if you need to buy bread, eggs, and milk, maybe you picture Superstore as being covered in like loaves of bread, then you picture the church as having eggs smashed all over it, and then you picture a big puddle in the middle of the soccer field, which is just full of milk. So basically what you're doing is you're trying to encode that information not only in the pathway, but also like in that visual way, as well as in the kind of the list of words. So hopefully that'll make your recall better. So you're able to kind of take like a mental walk down that path, and it can help you recall the things that you need to get based on the imagery that you've created. Another type of mnemonic, which you've definitely seen used before, are acronyms. So acronyms are pronounceable words whose letters represent the initials of an important phrase or set of items. So for example, scuba, you've all heard of scuba equipment, scuba diving. Scuba actually stands for self-contained underwater breathing apparatus. So you see that every letter in that phrase is represented by the initials in scuba, self-contained underwater breathing apparatus. So if it is a pronounceable word that you can make with the first letters of the phrase that you're talking about, then we will refer to as an acronym. However, if you take the first letters of a list of things you're trying to remember and they don't make a pronounceable word, we can still use it. We just use something called the first letter technique. So we use the first letters of a set of items to spell out words that form a sentence. So in the example here, trying to remember the different kind of taxonomy within biology, if you look at your first initials of these words, you'd have K, P, C, O, F, G, S, which doesn't really make any kind of pronounceable word. But in this case, what you do is you take that first letter and you make up another sentence or another phrase that contains words that start with those same first letters. So if you said King Philip came over for good spaghetti, or we used to say King Philip comes over for good supper, basically what you're doing then is you're saying, okay, well, king, I know I had a word with K, so that's kingdom. Philip, I know I had a word with P, so that's phylum. So you're using the first letter of the words to help you recall the information about the words in the list. So a number of mnemonic devices are based on the premise of dual coding, which I kind of alluded to a minute ago. So the fact that we're storing information in more than one form. So for example, if you're using that method of loci, and you are picturing, the milk and the bread and the eggs on top of these buildings and in these fields, then you're not only storing the information as a word list of things you need to get, you're also storing it as visual information with those images that you've created. So that helps us not only in coding, because it helps us lead to deeper processing, it also then allows us to be more likely to be able to retrieve that information as well. However, there is a caution for the use of mnemonics. They may help you with rote memorization, so as in, now I can recall the list, but that doesn't necessarily mean they're improving your understanding of the material. So it's one thing to say remember the list of the different taxonomy, criteria in biology, but like if you don't know what each of those mean or why you're remembering that information, the mnemonic is unfortunately not going to help you with that. So no matter how you study, you should definitely take advantage of what we call the testing effect, which is the finding that practice tests can improve exam performance even without any additional studying. So literally, if you were to sit down and study for a test and you asked yourself a bunch of quiz questions, you kind of quizzed yourself using, multiple choice or flashcards, that's actually shown to lead to improved memory for the information than maybe sitting down and, just reading through your book and studying. So you should always be making sure to test yourself on the concepts as you're learning, which is why your textbook and many other resources have those little quizzes built in that will help you kind of test your knowledge as you go. So that is it for today. We're coming in at just under 40 minutes, which is perfect. So this will be your lecture for tomorrow, and then you can do the last 10 minutes of the other one, so that'll make up your 50 minutes for today's class. Unfortunately, I know that's still pretty long, but it does fit within the criteria. And then Monday's class for Module 3 should probably be even shorter than this one, so you'll actually have even less for that class. So you can kind of balance the 3 lectures out over those 3 classes. So thanks for tuning in. I'm going to go ahead and record the 3rd module now, and I will talk to you then.